Hello students, this is lesson U3A02a. By the end of the lesson, you should be able to say I can use SSS to prove triangle congruence and CPCTC to prove parts of triangles congruent. Sorry, I got cut off here, but this should say this should say U3A02a, and this is CPCTC, okay? I'll explain what all these things mean in just a moment. All right, so for this lesson, we will need these two facts right here. So take a moment and write this down for yourself. So what I have right here, okay, SSS, okay, it's actually an acronym. It stands for side, side, side. If ever we have three sides of a triangle, if we have all three sides of a triangle, these corresponding sides are congruent. Okay, so this side is congruent to this side is congruent to this side, and this side here is congruent to this side there. Then what we have is a side, side, side congruent relationship. The two triangles are said to be congruent. If two triangles are proven to be congruent, okay, then based on the rigid motion, okay, that we had talked about, remember, in the past couple lessons before, okay, in Unit 2, based on the rigid motion then, the two triangles are congruent, so therefore the corresponding sides, the corresponding parts of congruent triangles must be congruent. So again, if two triangles are congruent, then it is true that the corresponding parts of congruent triangles are congruent. I will say that one more time. Corresponding parts of congruent triangles are congruent. Where do you see that on the screen? Well, yeah, it's this thing here. So that thing that I was saying before, corresponding parts of congruent triangles are congruent. That's what CPCTC stands for. So all corresponding, so I'm going to write that down actually so that you guys can see it. So again, CPCTC stands for corresponding parts of congruent triangles are congruent. There you go. All right, so we will need to utilize these two facts in the problems that we are going to look at in this lesson. Again, if the corresponding sides are congruent, then the two triangles are deemed to be congruent. And if the two triangles are congruent, then we can say that all the corresponding parts of the triangles must be congruent. All right, so let's take a look. So for this example here, okay, I want you to go through and explain why are the two triangles congruent, which corresponding angles are congruent, and then which corresponding sides are congruent. So based on this, okay, we can see, I'm going to write here in a statement and reason chart, this is statement and reason. There's no real thing, anything given in this example other than the diagram itself. So I'm just going to say, based on the diagram and based on the diagram givens, I know that PQ is congruent to ST. I also recognize that QR is congruent to SU, and I'm sorry, not SU. QR is congruent to TU or UT, and I also know that PR is congruent to SU. So these are the givens. All right, so now let's take a look, okay? So the two triangles, these are the three sides that correspond. So immediately, okay, I can use the very first fact that I gave you in this lesson, which is triangle. And it is important, okay, that the following has to be true. How you're calling the triangle, so for example, I'm calling PQR, okay, which is the triangle on the left. All the letters must correspondingly line up, okay, with the other triangle that I'm calling our congruent, okay? So it looks like it's going to be STU, triangle STU. Okay, they are going to be congruent. Notice that P corresponds with S, Q corresponds with T, and R corresponds with U. And why are those two triangles congruent? Oh yeah, because I have side, side, side. I have a side, side, side congruent relationship between these two triangles. So, and then the next thing that I needed to do was I needed to name all the angles that are congruent, okay, between these two triangles. What are all the corresponding angles that are congruent? We know all the corresponding sides already because I already named it in the givens there. Okay, so what are all the corresponding angles that are going to be the same? I know that angle P must be congruent to angle S. I know that angle Q must be congruent to angle T. I also know that angle R must be congruent to angle U. And this is all true because why? Because of corresponding parts of congruent triangles are congruent. And it is true for all three of these. All right, moving on. See if you can figure out this on your own. I encourage you to pause the video. So hopefully you had some time to think about this. So the first thing that we're going to do, and again, the task is to figure out all the sides that are congruent, all the triangles that are congruent, and all the angles, corresponding angles that are congruent. So the first thing that I notice here is that LO is congruent to OV. I'm sorry, not OV. What am I saying? Is congruent to LE. And I know that OV is congruent to EV. And these are the only two sets of givens that are provided for me in the diagram there. However, upon closer inspection, I noticed that quadrilateral LOVE is sharing a common side, or actually triangle LOV is sharing a side with triangle LEV, and that is LV is congruent to itself. This needs to be in place because I want to show that both triangles have all three sides congruent. All three corresponding sides are congruent. I do, as a matter of fact. So therefore, triangle LOV will be congruent to triangle LEV. And this is because of, again, side, side, side. I know, based on this, that angle L, or actually, let's start with angle O, is congruent to angle E. I also know that angle OLV is congruent to angle ELV. And I also know that angle OVL is congruent to triangle EVL. And why is this true? Oh yeah, because of corresponding parts of congruent triangles are congruent, and all three of these have the same reasons. All right, really similar. Pause the video, see if you can figure this out on your own. And welcome back. So the first thing I notice is MH is congruent to TA. I know that MA is congruent to TH. And upon close, and these are all givens. And upon closer inspection, I notice it's a very similar situation from that second example that we just looked at. AH is congruent to itself because this is reflexive. Amazing. All right, so therefore, triangle MAH must be congruent to triangle THA. And this is true because of, you guessed it, side, side, side. All right, so then what angles can I name are correspondingly congruent? I know that M is congruent to T. I also know that angle MHA is congruent to angle TAH. I also know that angle I also know that MAH, MAH, is congruent to angle THA. And the reason is, again, all the corresponding parts of congruent triangles are congruent. And all three of these statements have the same reason. All right, let's take a look at another example here. This one here is slightly more complex, so let's take a look. This is the statement, and this is the reason. And again, I encourage you to pause the video and see if you can figure this out on your own. Alrighty, so, So welcome back. What we have to do in this case, okay, is I immediately know that PS is congruent to UR. I know that TS is congruent to QR. I know that PQ is congruent to UT. All right, and these are our givens. Notice though, okay, PS is a side, is congruent to UR, and I know that PQ is a side, is congruent to UT. However, TS to QR, that is not a side. So for these two triangles right now, there's only two sides that are congruent. However, you are given information about a partial side. So our task in the next couple minutes is to show that this side here, TR, is the same length as QS. So how are we going to do that? If this is reminding you of segment addition postulate, then you're definitely on the right track. So one thing that we have to do, okay, is I want to say that SR is congruent to SR. And this is because of reflexive. So because SR is congruent to SR, and I know that TS is congruent to QR, I immediately recognize that the following must be true. I can immediately recognize that TS plus SR must be equal to SR plus QR. Actually, I want to change this for communications purposes. I want to call this RQ, so that I'll call this guy RQ. It's all the same, right? Okay, and why is that? It's because I'm adding, it's the addition between lines 2 and 4. All right, so what are we going to do next? The goal is to show that TR is congruent to SQ, right? So how are we going to do that? Well, I know that TS plus SR should equal to TR, isn't that right? And I also recognize that SR plus RQ should equal to SQ, isn't that right? So these two lines, okay, are made up of those different segments. And why is that true? Remember, this is a postulate. We do not need to defend this in any way because this is self-evident. Segment addition postulate. So these two statements are true for those reasons. Now, let's check this out. We're almost there because in step 8, okay, notice, what does TS plus SR really equal to? Oh yeah, that equals to TR. What does SR plus RQ equal to? Oh yeah, that's SQ. So therefore, I can say TR is congruent to SQ. And that is because of substitution. What am I substituting? Between which lines? 6 and 7 into 5. All right. And we're pretty much in the home stretch because, look, I have line 1, line 3, those are side, and this is a side. So therefore, I can conclude that triangle PQS must be congruent to triangle UTR because of side. And I'm almost done. I just need to list out all the different angles that are correspondingly the same. So I know that angle P is congruent to angle R. I'm sorry, it's congruent to angle U. I know that angle Q is congruent to angle T. I also know that angle URT, I know that angle PSQ is congruent to angle URT. And why is this true again? That's because of C, corresponding parts of congruent triangles are congruent. All three of those remaining statements are true because of the same reason. And that's it.